There are two very well-known formulas. In fact, if you have already finished all the examples in the previous two videos, you have already derived these formulas on your own. And they're called Demorgans-Laws, which states A union B complements equals A complements intersect B complements. That's the first one. The second one says A intersect B complements equals A complements union B complements. So, okay, so let's see how we analyze this De Morgan's law. It says that if I have two sets, so this is my universal set that includes everything, and then I would have a set A, that's blue, and then I will probably have a set B, that's red, okay? And they overlap a little bit. So let's find what we need. It says right here, we need to first find A union B complements. In order to find A union B complements, we need to find A union B. And that's fairly easy. We say unions are just additions. We add everything together. So it's everything in circle A and everything in circle B is A union B. Therefore, A union B complements is everything that's not in circle A or circle B. So it's where the green area, green dots are, okay? And then on the right-hand side of the equation, it then states that we want to find A prime intersect B prime. Now, A prime is where everything that's not A, or A complements, I'm sorry, intersects B complements. I had calculus in my mind. And so where it is everything outside circle A is A complements, including those units in those elements in circle B, in set B. But then we also want to find B complements and have them intersect each other. So it's probably better if I draw this. So because it's intersection, I'm looking for an area where I have both the yellow dot and the peachy dot. Okay, so like we said, A complements is everything that's not A, right? Everything that's not A, okay? And then I'm looking at B complements, therefore I'm looking outside the B circle. See that? Notice that I only have in A, I only have peach, oops, sorry about that. Notice in A, I only have peachy color in A. I don't have both gold and peachy. And in B, I only have gold color. I don't have both gold and peachy. The areas that has both peach and gold color is the green area. So we just proved that A union B complement is the same as A complement intersect B complement. Okay, that's the first one. The second one gets a lot easier. So let's look at the second one. We have a universal set. We have a blue A intersect with a red B. There we go. And then we said we are going to have, this time I will use the green again. So A intersect B complements. A intersect B is right in the middle. A intersect B is here. This is A intersect B. So everything that's not, that's its complement, everything that's not in A intersect B, whoops, sorry. Everything that's not in A intersect B, let me change this to a different color. Let me use purple instead. So it would be all over here. So a portion of B and a portion of A is the intersect, is part of this set as well. So now let's look at A complements union B complements. So I'm going to use red to represent A complements is everything that's not in A, including here, right? Everything that's not in A, plus B complements, because it's a union, I'm going to use the same color. B complements and everything that's not in B, I have to add it together. Did you notice that if I just keep doodling, what do I have? I'm covering all the purple one, right? Didn't I just demonstrate? My A intersect B complements is the same as A complements plus B complements, or A complements union B complements. So that's Demorgans' law. Here's an example of how to use this law to help us. We have two sets with various letters here. And so we first need to find, as I mentioned before, need to find A union B. And that's obviously A, B, C, D, E, G. That's A union B. And therefore A union B complements is just F, G. Right? And then we have to find A complements, which is B, D, F, H. And then we have to find B complements, which is A, F, G, H. And now we can find out their intersection. A complements and B complements intersection is just F, I'm sorry, it's F, not F, G, F, H. So that gives us the conclusion that we need right there. So give it a try yourself. This actually makes life a lot easier if you understand it. Just list them out and follow the rules and use the Demorgans' law as a tool, as a shortcut. Even if you don't know it, you can still operate it on your own, just based on all the rules that we learned previously. Here's another example. So we're asked to find, let's see, A intersect B. So it's the second one, A intersect B complement. So in order to do that, we need to first find A intersect B. I personally like the second one better because it's just, intersections are always less work, right? And once we find that, once you have that, you'll be able to find A intersection B complements is everything but 12 and 13. So that would be 10, 11, 14, 15, and 16. That's how we solve the first one. The second one, we need to find obviously A complements first, and that's 14, 15, and 16. And then we need to find B complements, which is 10, 11, and 16. And now if you just put them together to make a union of A complements and B complements, and that's 10, 11, 14, 15, and 16. So that's how we use Demorgans' law. Finally, I just want to use one example to illustrate how we use Venn diagrams to decide if two sets are equal. This is actually quite fun. There will be some practices we're going to do later, but I want to do an example here. So if we have to use the Venn diagram to determine if A union B intersect C, and see if that and A intersects C union B intersects C, and see if these two are equal. So we first have to find A union B. Let's see. A union B is everything in A and then everything in B, right? So if I use a color green, so it's region 1, 2, 3, 4, 5, 6. So everything in these two circles is A union B. Okay, that we took care of. And then obviously C is the green circle underneath, not the shaded area, the green circle underneath it, which is 7. It has region 7, 4, 5, 6, and 7. And where they intersect with A and B is just, let me use the gold color. Where they intersect is just here. That's the intersection. Right? So that's our first set. That's A union B intersects C. We just found that solution. Let's look at the second one, the peachy one. The red one. So first we need to find A intersect C. A intersects C, so it's where the green circle intersects the red circle. Region 4 and 5 are A intersect C. And then we have to find B intersect C. So because the final product is a union, I'm going to still use the red highlighter. So it's B intersects C, which is where the blue circle intersects with the green circle. And I would have this two regions. So it's 5 and 6. See if I can erase. Oops, sorry. I was trying to go for the eraser to make it cleaner looking. There we go. So that's the area. So as you can tell, the gold area, which includes 4, 5, 6, and the red area, which includes 4, 5, 6 as well. Therefore, we can draw the conclusion that, yes, these two areas are, two sets are equal to each other. Okay, so this is really just a practice of using Venn diagrams to explain sets. Make sure you complete all the practices and then go to the lesson plans and click on the links. There are several practices that are graded. Thank you, guys.